Hi, welcome back. Today's topic is random. We've already talked about introducing randomness into fractals. Today we're going to talk about what random is. It's a concept, what the concept random is. We'll also talk about the word random and at randomly and at random and things like that. The important thing is to get the concept, and I think by the end of this lecture you will have the concept. It will be a little vague, but then random is a little vague concept. Okay, let's define it first, or our usual non-exact definition. Random is when we can't predict a result exactly. And what we mean by exactly I will talk about in a little while, because that's a vague concept. For example, let's say I have a die, and a die has 6 sides, and there's a 1, a 2, a 3, a 4, a 5, and a 6 dots on the 6 different sides of a die. As a matter of fact, here's a picture. Here's a die, a big one so that you can see it. 1, and 3, and 2, and 4, and 5, and 6 on the face of the die. Now, if I roll the die, the number facing up is usually what we say, that's the result of rolling the die. In this case, it's 5. If I roll it again, this time 1 is facing up. So the roll of a die is not predictable. I can't really tell what it's going to be. I don't know. I know it's going to be a 1, 2, 3, 4, 5, or 6, but I don't know which one. I can't predict it exactly. The result of the roll of a die is said to be random. Not hard to understand. Sometimes we have what's known as partial information. Partial information, what do you mean by that? Well, that's easy. Partial information, I mean, I know that I'm going to get a 1, a 2, a 3, a 4, a 5, or a 6. I'm not going to roll a 7 with 1 die. I'm not going to roll a 9 with 1 die. If I have a coin, and here's a good-sized coin for you, heads, tails, I'm going to flip a head or a tail. I'm not going to flip a 2 or a 3. It's going to be a head or a tail. So I have that much information. When I flip a coin, the result's going to be heads or tails, but it's not going to be 2, 3. So I have partial information. That doesn't change the fact that I can't predict what it's going to be, and therefore the result of a flip of a coin or the roll of a die is random. Another word that I'd like you to learn about is equally likely. Equally likely. When I flip this coin, it could come out head, it could come out tail. The coin is balanced. There's no real reason when you flip it and it goes up and turns around lots of times. There's no real way to predict whether it's going to be head or tail, and there's no reason for it to come up heads more often than tails. It's a balanced coin. So heads and tails should come up about the same. And we say the coin is equally likely to come up heads or tails. When we roll a die, the die is balanced. Equally likely for the number to come up to be a 1, 2, 3, 4, 5, or 6. Equally likely. Well, okay, it doesn't have to be equally likely. We could unbalance the die, put some lead on one side so it comes up that side more often than it should, but it still can't predict what's going to happen. We don't have to have equally likely outcomes for us to think of random. Random is simply because we can't predict it exactly. How about your grade in this course? Is your grade in this course random? And lots of people say, oh, no, of course not. I'm going to study it. It's going to be a good grade. Well, yeah. You can study, and chances are you'll get an A or a good grade, but there's no guarantee. Even if you study, you could goof off on the final. You could just have a headache or something. Who knows? Lots of things happen, and you could not get a good grade. You can't predict it exactly. The grade on the course is random. Don't go around telling people that you're being graded randomly, because we'll talk about randomly in a little later. Your grade is not given to you at random or randomly, but the grade in the course is random. The concept, random. Who will win an election? Who will win an election? Well, I can't predict who's going to win an election. Obviously, who's going to win an election will be random. Even though all the television polls tell you so-and-so is favored, and you know the election isn't over until the last vote is counted. So we don't know who's going to win an election. We can't predict it exactly. There comes a point where the candidate concedes. He says, you know, there's really no chance that I'm going to win. I'm behind 10,000 votes, and there's only 9,000 people left to vote, so I can't win. There's no real chance of my winning. I will concede. Okay, by that time you say, I can't predict it exactly. Let's talk about exactly. Exactly doesn't mean the same thing to you and me at this present moment. In terms of flipping a coin. If someone were to take a coin out of their pocket, a coin, I don't know whether it's one-sided, two-headed coin or what, and they start flipping it, and they get a head, and another head, another head, another head, and they flip it 100 times, say, and they get 100 heads in a row. And then they say to me, all right, what's going to be my next flip? And I say, a head. Well, we'd all say a head. Is the result of that flip random? The answer is no. No, it's not. It's a two-headed coin. There's no question about it. If you, from the moment you were born until now, were to flip coins 100 times as fast as you could, let's say it took you 10 seconds to flip a coin 100 times. If you were to do that over and over and over and over again, every 10 seconds for all your life, not one of those batches of 100 flips would be all heads. Because there's no chance of flipping 100 heads in a row with a fair coin. No chance whatsoever. So clearly, it's a two-headed coin. Now, okay, how about 5 flips? Someone flips a coin 5 times and get 5 heads. Does that mean it's a two-headed coin? Well, no. I've seen someone flip a coin 5 times in a row and get 5 heads. That's not a real problem. So 5 heads in a row doesn't make it a two-headed coin. 100 flips in a row does make it a two-headed coin. Where's the dividing line? Where is this exactly? I can predict it exactly. See, there's always somebody going out there and interpret exactly in the philosophical sense to say, oh, well, maybe we're a figment of somebody's imagination and we really don't exist, and therefore there's no meaning to head in the first place. We don't talk that way in statistics. When we say exactly, we mean beyond a reasonable doubt. 100 heads in a row, totally unreasonable to expect it to be fair. 50 heads in a row, totally unreasonable for it to be fair. 20 heads in a row, pretty much unreasonable for it to be a fair coin. So if someone flipped the coin 20 times in a row, I would know that it was a two-headed coin. Now, does that mean I couldn't be a figment of somebody's imagination? Of course I could, but you could flip coins 20 times in a row for your whole life and still not flip 20 heads in a row. And so I would say, there's really no chance that that's a fair coin. That's got to be a two-headed coin. And so I can't predict it exactly. Okay, now we're down to 20. I can predict it exactly. 5, I can't predict the next flip exactly because I don't know whether it's a two-headed coin or not. Where's the dividing line? Is it 10? 15? Where do I say it's a two-headed coin? 15? 10? Where? We know I'll say it at 20. I won't say it at 5. Where in between would I say it? Well, personally, I guess 15. Someone else, just as good a statistician as me with as much experience, might say 10. Okay? There's a broad range of reasonable meanings to the word exact. How exactly do you have to be able to predict it? How precise does it have to be? Well, it depends on who you are. There is a reasonable range of disagreement, but there are ranges where it's not a disagreement. 20 should not be disagreed by anyone. 5 should not be disagreed by anyone. But I must admit, in statistics, and you will see that, not my fault, words in statistics are a little bit a little bit fuzzy, a little bit fuzzy. They don't have precise meanings. They have a little vague meanings. However, there's a limit to the vagueness. And although in this class we tolerate some vagueness, we're trying to show you where the limit is and don't go over it. And if I say, yes, at 20 flips of a coin it is unreasonable to say it's a fair coin, then you'll go along with me and don't argue, okay? It is unreasonable. That's what I mean by exact. So what do I mean by exact? Something that's not very exact. All right, a result is random when we can't predict it exactly. We know we just talked about what we mean by exactly. Even when we can restrict ourselves to a few possible outcomes, a few possibilities, and even if one is favored, I still can't predict what it's going to be, and therefore the result is random. So a result is random when we can't predict exactly what the outcome is going to be, even if we have just a few outcomes, a head and a tail, as few as you can get, I guess, and even if one of them is favored, even if the coin is balanced so that heads will come up more often than tail, it's still random. Okay, is your ID number random? Well, now that brings us to another problem. Another problem entirely. Is your ID number random? Well, if you were to come to me and say, guess my ID number, I'll look at you and I say, well, there's 300 students in the class, and I have a roll here. I can't even tell which one you are, let alone remember the ID numbers of everybody in the class. So if I were to give you a number, it would be pure guess, and there's really not much chance that I would guess right. So to me, your ID number is random because I don't know it. However, if I were to ask you for your ID number, I say, what's your ID number? You would say, oh, 22743, and you would spit it right out. You know your ID number. It's not random to you. Random depends on our point of view. So random is not a property of the happening alone. It also depends on our point of view. Your ID number is not random to you, but it is random to me, because my point of view is different than your point of view. Let's consider this die. All 6 sides are 5s. And actually I have one of those here. Here's a die. Every side has a 5 on it. Now, Johnny comes late to class. And we have this die. Hey, Johnny, we're playing game here. We're going to roll this die. Okay, how many dots facing up, Johnny? To him, the number of dots facing up is random. He can't predict what it's going to be. He'll say 1, 2, 3, 4, or 5. He won't know. To us, it's not random at all. We know it's going to be a 5. It's not random to us. It is random to him. Okay? Any problem there? No. Random is not only a property of the happening, the flipping of the coin or the rolling of the die, it's your point of view. It's how much you know. Whether you can or you can't predict it exactly. If you can predict it exactly, and we know what exactly is, it's not a precise thing, but we pretty much know what exactly is. So we can predict it exactly, because someone's going to say, what if it falls in a crack and stands on edge? We're going to forget about something like that. It's going to be a number. We can predict it exactly. Okay? So if we're in that situation where we can predict it, it's not random. If you don't know that it's all 5s, random as anything else. Okay, now, some things are more random than others. What if we had a die which had 5 5s and 1 2, say? And we were to roll that. Now, we all knew it had 5 5s and 1 2, and we were to roll it. Well, it's much more likely to be 5 than it is 2. In fact, most of us would figure out this 5 times as likely to be a 5 as it is a 2. It's more likely to be a 5. So some things are, we sort of get the feeling that this is not as random as the fair coin. If I take a fair coin, this thing here, it's more random than this is. This is less random. So some things are more random than others. we get this feeling that there is a sort of a maximum randomness. The maximum randomness comes when things are equally likely. When things are equally likely, it's sort of a maximum amount of randomness, and when one is really favored, it's really the least amount of randomness, but it's still random. However, this maximum amount of randomness, when things are as random as they can be, we like to give a special name to it, and we call that at random or randomly. If we were to pick someone at random, it would mean I'd have to put everybody's name in the hat and draw a name, so that each person has an equal possibility, an equal opportunity of being the one chosen. Each one has an equal chance of being chosen or occurring or happening. That would make the choice at random or randomly. If I randomly pick someone, that's the same as picking them at random. Randomly picking them or picking them at random. That's the most randomness you can have, and that's when things are equally likely. Okay, so we have a little feeling now for what randomness is. Just a little. It's a little bit vague, but it's not really that vague. Most of us will have a feeling, an understanding without defining it, a feeling for when something is random or when something isn't random, and to whom it's random and to whom it's not random. And this is the concept that I want you to get. I want you to be able to tell when something is random and something's not random. And if you've got that, you've learned today's work. Okay? Have a happy.